we're given that the square root of x plus p plus the square root of x equals p has at least one real solution for x, where p is some real constant. We want to know what is the complete set of possible values for p. We're just going to dive headfirst into this and try and rearrange this. So we kind of want a square, but it's a bit awkward with both the square roots on the same side. So let's bring one onto the other side. So we get root x plus p equals p minus root x. Square both sides, and we get x plus p is p squared minus 2p root x plus x. Those guys cancel. If we bring everything to one side, we get p squared minus 2p root x minus p equals 0. Let's factor out the p. We don't want to divide by it because it could be 0. Factoring it out, we get p minus 2 root x minus 1 is 0. Okay, cool. So this gives us two possibilities here. So either p is 0 or root x equals 1 minus p over 2. Sorry, I've got that the wrong way around. P minus 1 over 2. And so therefore x would be p minus 1 over 2 squared. Okay, cool. But we do just need to check that these give us solutions. So if p equals 0, does this equation have a solution for x? Well, we get root x plus root x, that's 2 root x, equals p, which is 0. And that obviously has a solution x equals 0. So that means p equals 0 is good. It should be part of our answer. Okay. Okay, sorry, what if x equals p minus 1 over 2 squared? Well, the left-hand side will become root x plus p, so root p minus 1 over 2 squared plus p plus root p minus 1 over 2 squared equals p. Okay, let's simplify this. Well, this thing here is p minus 1 squared, so p squared minus 2p plus 1, and if over 4, and so if I add p to that, that's going to be p squared minus 2p plus 1 plus 4p over 4, so the square root of that, plus, now you might just say that this is p minus 1 over 2, but that's not quite true. This is going to be either plus or minus p minus 1 over 2, depending on whether p is bigger than 1 or less than 1. And that equals p. What about this guy here? Well, that's just going to be the square root of p plus 1 over 2 squared. And again, same thing. That's just going to be modulus of p plus 1 over 2 plus modulus of p minus 1 over 2 equals p. So we need to determine what values of p make this true. And, well, we can just verify this. If p is bigger than 1, if p is bigger than 1, these two things will be positive. You'll get p plus 1, p minus 1, add them up, you get 2p over 2, which equals p. So this does indeed work if p is bigger than or equal to 1. Cool. What if p is between minus 1 and 1, sorry. If p is between minus 1 and 1, well, this first bracket here, so this one will be negative, but this will be positive, and then you get the p's cancelling out, and you get like a half plus a half is p, and so you get back to p is 1, which we already know works. And what if p is negative? Well, we don't need to check that. If p is negative, this is a modulus, this is a modulus, that's going to add up to a positive number, and so wouldn't be able to equal p. So the only possible solutions here are p equals 0 or p is at least 1, and you can actually just check both of them really quickly by plugging them in. They do work.